Regret again. Good morning again. This is Yasur Singh speaking from Bharat, India. Again, there was a problem in last video, so I extended my revision. Another one, last was stopped, interpret. I don't know due to signals. What to do is not my control, it's not my control. So it's another one, revision one, action 305A. I was talking about role of site engineers, role of application, contemplation, thinking, synthesis, analysis, reliability, risk, cost, time, method statements, construction, designs, quality. And quality is leader here, you can say. Quality doesn't mean material quality. Quality means quality of total project. So quality, designs, construction, method statements, time, cost, risk, reliability, analysis, synthesis, thinking, contemplation, application is ultimate answer. There can be so much in between this. I'm just giving some titles here. Means what is quality? Plus means quality of total project. It includes designs, it includes construction, it includes various methods, and it takes into consideration time factor, cost factor, risks factor, reliability factor, say which equal to safety, serviceability, and of course durability, and it all based on individual analysis, independent synthesis means combination of all results of analysis and thinking further and contemplation further, application light. Every step has got certain operational researches, and that must be taken care of. And we talk of role of site engineers. It's very important. I explained in last video, which is linked to this one, and that's very important point. We have to consider what, after all, this production site engineer is, or you can call project engineer or project leader, or by whatever title one can call it. But site engineer, or actually engineer, you may say executive engineer, and if site engineer itself becomes a designer as well, which is very rare. Means it can be in case you use very small project that you have to design yourself and you have to construct yourself. There is no miracle in that, or you can say it's not extraordinary, because small project can be handled by one person who designs it. Though it's not very common, but it doesn't mean because this is era of specialization, everybody considers as specialized. I'm specialized in design, I'm specialized in planning, I'm specialized in prosecution, I'm specialized in that. So when everybody is a specialist, I should say nobody is a specialist. I can say everybody is a specialist. So you are a specialist in your world, in your sub-discipline. You can say specialize is nothing but engineering sub-discipline. So you are only sub-discipline engineer, not even discipline engineer, not even field project engineer, or you can say you are not even civil engineer. Please don't mind it. This is fact. There was a time when everybody was civil engineer. There was no computer, there was no calculator, and structures were built that time also. If you go back into history, you'll find there was not even degree in engineering or diploma in engineering or some other titular course in engineering, yet people had knowledge. They did lot of projects. So it's not that even a sparrow or birds, they construct their own houses, small houses, we call them whatever nets, and they stay in that. So they are also to some extent small engineers. So don't take it otherwise. Here we are considering those who work in field in all weather conditions. Those conditions can be hot or cold, rain or no rain, and they live and work like this, not even 8 hours. Many people work 12 hours, 14 hours, 16 hours, and during concrete, even for many days, that activity continues, and those professional work, maybe in shift or no shift, that's different. But roles are very much varying, and I'm not going to explain all roles. Here are only few roles which are of certain importance that we are going to discuss, because yesterday I lost all this due to absence of technical defect in voice recording, and now I'm again doing same thing because it is required. You see, prior to deliberating role of site engineer on job, when I say job, this means project. Let us understand what definition of site engineer is, or engineer is, you may say. In nutshell it is. It's not well defined, it's not elaborated. Site engineering indicates a chain of various engineering works or engineering activities, descriptions belonging to all disciplines, starting from tender stage to handing over and maintenance stage of a building or structure or project. This is very brief definition, but it includes a lot. This time now, in this era, it's not alone civil engineering, which is site engineering, because every site is served. Every building, every structure is served certainly by other branches of engineering to support structure, to support civil engineering product, that is structure, and that support for service is admitted and is extended by mechanical engineers in form of HVAC, that is heat, ventilation and air conditioning, in plumbing, in sanitation, in structural engineering, structural steel, and also from electrical engineers that comes into wiring, load distribution of structure, loading of electrical power that comes for low voltage, high voltage, that comes from adjustment of supplies to various areas, and also it comes from other engineers, for example, elevators, escalators, travelators, and also from security engineers like system of closed circuit television, systems of access, and also systems of electronic requirement or IT, like raised floor system. Means there is no limit. Whatever service is required, that is to be provided to every structure. So civil engineering plus those sub-disciplines of various other engineering, and of course landscape, which I forgot, which is internal as well as external. Internal decoration by plantation, artificial or non-artificial, and also external agricultural plantation, landscape, soft landscape and hard landscape. We call both. And you can say various other facilities like in some school buildings, sports surfacing. Means there are in some institutional buildings or some other building, for example, theater, or you can say atrium, assembly halls, laboratories, workshops. Means there's no limit. In brief only I explained about civil engineering, but civil engineering equal to, if you really call it in these buildings, civil engineering plus part mechanical engineering plus part electrical engineering plus part security engineering plus part like that. This means civil engineer has to coordinate with all such sub-disciplines. I'm not saying the civil engineer would do that as a specialist, but as a specialist coordinator. It is coordinating job. Coordination means you have to stand with them. They have to stand with you. Meaning of coordination people must understand first, because engineers don't care about terms and they miss many times. Engineering doesn't mean that you have to just analyze and design or do it. That everybody does it. That's only part of your job. When you take into consideration construction, particularly construction or production of designs, or giving shape to whatever designs one gets from contract documents or project documents, those parts must be taken into consideration, that all activities from all sub-disciplines and your disciplines stand in time without any variation. When you have to do it, every information must be available through drawings, through specifications, through production, through delivery of materials. No plant, no machine can be procured without having determined, without having making decisions which relates to compatibility of machine itself and its electrical supply or its others. So when I say coordination, coordination means every information must be available at time of applying whatever activity we do. That's what I said, application. Application involves information from basic discipline, that is our own civil engineering or structural engineering, and supported by informations achievable or received from all other engineering disciplines. Same time, simultaneously, no variance. You cannot say today we have to do this, tomorrow we get that information from mechanical or electrical will apply. No, that is not admissible, that is not acceptable. So coordination means I stand as civil engineer and others, my colleagues who come from other branches of engineering must stand with me in interest of that work, in interest of that activity, in interest of that project. Same time, everything should be available. My drawings and their drawings should be available in status as AFC, approved for construction, or you will say those drawings which are valid for construction. If this doesn't happen, work cannot be done. So coordination can come as, you can say, accelerator of work, as mover of work, and also it can come as obstructor for work. It can stop your work. We cannot blindly say, okay, I am not getting this information from HVAC or mechanical or electrical, but I can't wait, I can't stop, I have to do it. No, that's not possible, because this is against project interest. You cannot do something in absence of information, and you have to wait for that information, and that means delay. That means waste of time, and waste of time means hold on job. So site engineering indicates a chain of various engineering works, descriptions belonging to all disciplines, starting from tender stage to handing over and maintenance stage of a building or structure or project. Now, there are certain further considerations. There is always one person who works, who produces, who works on site and actually physically is responsible to produce that on site. I'm not saying deliver, to produce that on site. And other person, one who examines that activity, who keeps an eye on that activity in addition to eyes kept by that worker, that engineer who produces them. So that person who produces that on site, we call him construction person, and he stands on construction end, while other person who just supervises that whatever construction is being carried out, that is, that complies with the conforms to whatever is required within contract documents, all contract documents. There's no variance except tolerable limits. That person stands at supervision end, that is responsible for supervision, surveillance, or you can say such support. But still, responsibility lies with construction end. So what I say, supervision end is just contractually, if you do contract work, call that person responsible to work on behalf of engineer who designed that project and is responsible for all actions on works, and that person is supervisor, or in a contractual term we call that person is responsible for designs and supervision, named as engineer, and that person who on that engineer's behalf supervises practically, physically on site all those works is called resident engineers. This term, resident engineers, is just a term. It's a term in a language of understanding. Resident means representative. It doesn't mean anything else, or you can say agent. This person is known as agent of engineer. Engineer means a person who has been deployed by honor to take care of that project. So engineer is term which is dominating one, which is contractual and also professional term. Engineer and its junior or support, that's called resident engineers, which means representative engineers. That engineer works on behalf of engineer to take responsibility of execution, but total responsibility still lies with the engineer only on behalf of owner, on behalf of project, and not of resident engineer. Resident engineer is responsible for all activities being physically carried out on site, qualitative-wise, quantitative-wise, and all otherwise contract-wise, but ultimate responsibility, including finances, go to engineer. This is general term, means no changes can be made even by that engineer if budget is not available. No augmentation can be done to project cost. No augmentation can be applied anywhere except with permission, by permission of owner, because money is affected. No one has money. Without availability of money, you cannot increase project cost. Yes, reduction can be done. So at this another end, that's called construction end, which I say, where you can say site engineer works, project engineer works, of course, if not project engineer, project executor engineer, or you can call agent of contractor. You can call by whatever term. If there's no contractor, you may do yourself. Then you are a representative of construction, you are construction representative. But generally, because projects are done through contract system, so contractors representatives like engineers representatives or agents too who are there on construction end, and that person is called site agent or site responsible engineer, and also contractor is responsible in totality. So these are two levels. Let us now see brief on supervision end. What we say on supervision level, engineers are deployed in capacity of resident engineer to work on behalf of contractual engineer. In contractual engineer means an engineer specified or defined within legal contract documents. Contractual engineer further delegates executive supervision powers to resident engineer. That is, contractual engineer delegates power to its resident engineer. Within governments, in particular our country, India, Bharat, and also I think in many other countries like UK and others in past, there, to my awareness, I'm not guaranteeing that, there are 5 categories of engineers since beginning of this country's independence, and those levels named chief engineers to junior engineers, covering middle levels like superintending engineers, executive engineers, assistant engineers. One end is chief engineer, and other lower profile is junior engineer, while chief engineer is really engineer. We can say chief engineer is originally responsible for all contractual decisions as head of department. Project should come under authority of chief engineer as contractual engineer, and all further engineers described in down titles should be considered as resident engineers of various levels and titles or designations. And construction end, we can say, if you go to construction end, we may say project manager or project leader or project engineer. All I call project leader rather than calling them manager or engineer. Or actually, they are real organizers of construction, downwards to frontline workers, frontline professionals, foreman, supervisor, and charge are assigned in construction contracting company. These are titles like, and these designations or titles are factually responsible for achievement of project construction, execution, deliveries. They physically deliver what was required by design or what was required by theories. They actually convert all those information into physical being. An engineer who represents company means an engineer who represents company or client or operator on actual site, physically and functionally reports to engineer's representative. You can say an engineer who reports to engineer's representative or resident engineer on site, that is designated as site agent. I am talking of contractor's representative, or a person who takes responsibility, delegated responsibility from contractor, and they call generally site in charge, depending upon contractual requirements at construction end. And this engineer is designated, entitled site engineer, responsible site engineer, accountable site engineer for this project. And generally, that is a lead professional in contracting company on site. Then we come further, resident engineer and site engineer. Virtually, resident engineer and site agent, I think they can be considered equal level on site organization at various locations and on behalf of different parties, because resident engineer is responsible for all works of supervision carried out on project, whereas site engineer or site representative remains responsible for all works of constructions carried out by contractor on project. All engineers subordinate supervising engineers. You can say engineer subordinate, I'm talking, not contractor subordinate. Engineers subordinate supervising engineers, report to resident engineer and work for contractual engineer. That is engineer in contract. All site staff of contractor of whatever level, including subcontractors, report to site agent or project leader. Site agent or contractor's agent or project leader. Size, magnitude of project dictates, demands, strength, respecting further site staff to meet requirements, whatever are included in contract. Many site engineers practically, dedicatedly supervise all works, may be employed on various sections of projects. In many constituted teams under senior site engineers or construction leaders or managers. Various sections are organized under quality requirement system on all projects. Various sections are involved, and those are very descriptive and specialized disciplines, subdisciplines. Let us consider safety. Safety, HSE, health, safety, environment, supported by ergonomics, that's called safety. Then comes to that, of course, engineering, which is completely important department, important section of engineering, which relates to design review, which relates to coordination of all details, and also issuing all information to site to requirement. Engineering spectrum of technical world, and also then planning, or you can say scheduling, how to chart out program or scheme to do job on site, and also is part of planning, plan, do, check and review. That is another kind of planning, not actually scheduling alone. So this planning is very important. It also relates to cost control as well, which is in contracts. And then contracts means you have to take care of contract and administration of contract, very lengthy, very detailed, voluminous subdiscipline which controls all contract documents. And then real world of engineering exposure, you can say, to public, and that is construction, which is seen by eyes, which is witnessed and which is seen by all. That is construction, which general public thinks that it's only engineering, not safety, not engineering, not planning, not contracts, not surveying, all that. Construction, which is seen by everybody, is considered engineering, and when surveying is also seen by everybody, so that too they understand something. It's also part of something. These two important terms, construction is particular, which is everybody who is not civil engineer or other engineer, that person thinks that construction is only engineering and it is done just you do yourself, means they think every person can do it. And also then quality, we have discussed at length and we will keep discussing. Quality in totality and materials specifically, which are very important part of the sections. Material procurement, material decision, material procurement, material delivery, material testing, and material inclusion onto project. And then other non-disciplinary, non-engineering disciplinary section is of course very general. That is administration, public relation, which is a part of supporting all these disciplines. And these are various strong, typically established on generally every major sites. There can be more on this. There can be on sites disciplines like dispute resolution and many other issues, you can say. There can be, or if required, means you can say a review of all such disciplines. Well, all these sections are assigned relevant detailed roles to act on project, and roles are defined in project quality plans or project plan, which is must for, device must, though it may not be required in the system as a primary document, may be primary or it may not be primary, but this is very significant document. This is a specific plan for project in terms of quality. It must be considered accordingly, and we cannot go otherwise. So roles are defined in project quality plans or project plan, which must be taken care of, and it should not be that much complicated. It should be only that level complicated that it can be applied with. Just making more and more complication cannot solve problem. Problem can be solved if there's simplified method. You have to understand that. Now, certain executive engineers, site execution engineers' role in this, what is actually execution? Execution, if you say, people actually have got confusions. Execution is, for example, construction execution. You also can say design execution. Execution means something to do as a result. You execute something, documents are executed. There's no physical work there, but it's executed. We say, we have executed this contract. We have executed this agreement. Means something has to come into being. That's called execution. You sign, two parties are there, you make one document, but don't sign. Then it's not executed. If you sign both parties and somebody ratifies that, that's called execution. So what we consider about site is certain acts, certain stages that every construction site requires. And these are very, very limited one. I'm not giving everything. So let us say takeover of site takeover, then site planning activities, its mobilization activities, its surveying activities, its kickoff or start activities, construction activities. Then of construction means quality activities as well, and supervision as well, and then completion and maintenance. These are very, very, superficial activities which can't be removed. You have to take over, you have to plan, you have to mobilize, you have to survey, you have to kick off, you have to construct, you have to quality, you have to conduct supervision, like that. You can enlist it further, but I'm just trying to give only that part which is understandable by everybody. You can say what is, lead or leadership or management, organization. Because this document is very old, so I'm not written lead or other one. I try to leave to you. Management is very general term, though I don't agree with this, but it is. Because it is telling here something, gender. And when you just keep man there, means woman is missed. But here, woman management also I can say. Man woman management, organization, leadership. It's involved in general with site engineering and site coordination. It's everywhere. In construction, I'm just confining to site engineer has no definite independent direct role on quality because it has to do quality. Indirect role to implement design, engineering, and project decisions to comply with quality systems with strongly extended base supports by all responsible discipline sections on project. Quality plan, which is related to site, is called site quality plan, and site safety plan must describe functionary as well as reporting roles respecting all responsible engineers on project. Since site agent or site representative is responsible in all respects for site working, for site movement, role multiplies as follows. This very small description only. Design review, first involvement, to make sure that design specification requirements have been included within design philosophy. Engineering section does it, that is design review. If it's a part of contract or not a part of contract, even then design review can be done. It's in interest of project, in interest of contractor, in interest of client, that you can say technical safety it is, engineering safety it is. Maybe design is not compatible, probably. That's from that view, or it is not constructible, there could be. Means it's very difficult to construct what is given in details. And we have to consider, we have to contemplate, can it be revised? Can we change to a stage where construction becomes easy? It becomes friendly. Because we are interested in quality work. We are not interested, we have to do difficult work. Difficult work doesn't mean quality work alone. Work should be practical, work should be done in a way quality can be achieved. And doesn't mean that should be complicated sometimes. Excessive complication is caused by designers, which doesn't give ease of working on site, ease of workable construction, and it includes unnecessary time. It delays all those activities by say certain percentages of time, and that can become burden on contract as far as contract data is concerned, recoveries are concerned, damages are concerned. So soil report requires a thorough review through engineering section. We have said design review, now soil report, which should be reviewed just to know whatever we are doing or whatever is expected to be done is okay. And it's also better that ratification or making sure that soil report is right is to make sure that recommendations included by soil and geotechnical engineer have been covered within design report. In case of a pinpointed observation, it should be brought to notice of designer through agreed procedures. Should also be specified on design drawings, a specific value of soil parameters adopted on design for reference, because sometimes even by visual procedure we can understand what capacity of the soil may be as far as bearing is concerned, bearing strength is concerned, bearing capacity is concerned. Certain parameters must be confirmed on site prior to laying foundation. In case localized soil does not allow adopted design parameters. What I'm saying is, in case localized soil does not allow adopted design parameters, design should be reconsidered. That's the point. In case we have better soil, better strength, as based on which design is not done, but design is done on lower strength, design can be revised. You see, in case your soil does not allow design parameters, design should be reconsidered also. Depends on actual site load test. But it's not generally done on small projects, it's done on major projects where there are chances that design may be revised. Or let building be more safer. It is a responsibility of site engineer to conduct this test. I mean, site contractor, I should say. Engineer is a medium there, is journalist there, a spokesman there. It's the responsibility of site engineer to help us to conduct this test in all major areas of site. And quality engineer must involve for accuracy of that test and also interpretation of results. A variation from soil report should immediately be reported to soil laboratory and designer, where now resident engineer has to make sure that testing system is complied with, is conforming to requirements, is aligned to standard procedure. All relevant engineers must sign inspection and testing plan for such activity. This is just a brief of what I said. Role, it's not total role, it's just a small part of role. Because testing of materials, if saying, according to specifications, requirements, it must be conducted to ensure demanded quality adherence, quality adhering materials, particularly reinforcing bars is an important item for purpose of procurement rightly. Concrete trial mix should also be conducted so that right quality or required quality mix is produced to meet design requirement. This testing is very important for all. It's not just one material, it's for all important permanent inclusible materials, all materials. We'll talk of later. I'm just now giving role only. I'm not giving technicalities of that. And we can say piling, which is also very, very significant material, significant action, significant activity, basic activity, and without which nothing can be thought of in such strong cases, for example, high-rise or weak soil structures. Piling should be done fully in compliance to specification or specific design and test load requirement, load tests as well as integrity test must be rightly or satisfactorily conducted. Connections between pile cut-off level and pile cap should be rightly or satisfactorily made. Test piles activity must be conducted much in advance. Now we are coming to other role, and that is site engineer through engineering. Site engineer through engineering must make sure that all drawings contain right ductile detailing of reinforcement. This is very basic now, this is consideration. And in case of whatever detail missing, should raise immediately a query for confirmation. Arrangements must be indicated on typical standard drawings by designer. Very significant for proposed materials to resist forces, which included materials should conform to standards without any kind of adjustments. Means materials should be fit for intended purpose to resist forces. No compromise should be made in quality of these materials. Generally, it is RCC structure. Generally, it's RCC material. You can say material, composite material, combined material. Reinforced cement concrete, that is often included on various buildings. and it is certainly considered for designs. Therefore, it's significant to produce concrete works with good quality, acceptable, not acceptable, good quality, or you can say augmented quality or added quality, and no batch of concrete should be allowed to be poured unsupervised. Site engineer must ensure about whatever precautions are required to be taken on site should have been explained to all responsible skilled artisans and craftsmen as well as foremen, supervisors and charge hands. All requirements should be included on relevant method statements explicitly and clearly. All detailed method statements should be approved ahead of pertinent activity. All quality control must be conducted during concrete pour. These may include slump test, air voids test, volume, concrete temperature test, concrete mixing to concrete finishing, time, etc. Very brief it is. And we can say in this all steel bars or reinforcing bars, details must be produced in form of bar bending schedule, in brief we can say BBS, prior to giving to fabrication. That must be done according to standards. I used to do according to BS 4466 long back. Now it's 8866. I'm sure I did not go through that. This should meet requirements to avoid stress localization as far as practicable. Overlaps should be avoided. Rings or shear stuffs should be fixed in such a way that hooks do not continue on one side. It should be remembered that reinforcing bars during earthquake action time change behavior drastically. These bars provided with gravity actions loads, start accepting horizontal shear, distributed stresses, thereby forcing beams to work as columns virtually and columns to work as beams virtually instantly for a few seconds. Not as continuous loading, but just within a fraction of seconds when forces of earthquake are generated. That makes an essential requirement to tightly bind all bars, and no bar should be displaced during concrete pour or during vibrator application. Vibrator must not be allowed to touch any rebar any time. No over vibration should be allowed. No pulling or pushing of concrete using vibrator should be allowed. No concrete segregation should be allowed. No concrete must be vibrated. All concrete must be vibrated. No vibration means you are destroying concrete. In case of voids formation, though it should not be accepted, thorough investigation should be conducted and then remedial actions resorted to, even if you have to take out that part of concrete. You have to. If it's not reinforceable or if it's not concretable or repairable. Proper inclusion of concrete spacers, concrete covers, also called covers, should be provided at right locations so that reinforcing bars keep intact during pouring activity and adequate cover is available. It has generally been noticed that this item is ignored or neglected by site professionals, engineers, as well as by other persons. Cover or concrete space is too serious an issue, and that must be considered. Precast covers of concrete, if strong enough to bear loads, You know, precast covers, well cured, can be used, which is family member of concrete. It can be concrete cover, and it can be precast, put wires in, binding wires in. That is one possibility, and which is better one if you cast on your hound, making some timber frame of thickness of that cover equivalent, and we produce hundreds of covers, many hundreds of covers in one frame, even of 1 meter by 1 meter. So precast covers, well cured, can be used. Also plastic covers, if strong enough to bear loads of foundation reinforcing bars, can also be used. Formwork should be erected based on correct and safe designs of preparatory works. Working safety is of utmost importance. Working safety first criteria should be fully considered and implemented. Well, in addition to usual quality control tests such as slump or cubes, compressive strengths, additional tests should be considered for coarse drill or taken out from various locations to make sure that site conditions match laboratory conditions for cube testing purpose. Curing is responsible for life of concrete and therefore must be given due care and control under direct command of a responsible staff or key personnel. No leniency or worry about cost of water or curing compound or Haitian cloth or polythene sheet has to be accommodated. Care must be taken. Do not concentrate too much on cost of curing, because this is essential. Like your heart beats, like your soul works, that way curing is. The effects observed after striking forms should be reported to site engineer by foreman or by charge hand or by whoever, and through whom to resident engineer for remedial actions proposal, because you cannot change something yourself. If there's a defect, it must be conferred with everybody and with proper agreement approval that repair can be done. No horizontal planes of weakness should be accepted or preferred. As far as practicable, concrete pouring should be planned for monolithic concrete action. Monolithic means one time, beam, column, slab, and if possible, though it's not possible, columns as well. We tried this one in one small room and we have been successful that time, but I think that's not very common. It should not be taken just for risk. No, don't take it for risks. So as far as practicable, concrete pouring should be planned for monolithic concrete actions. As far as practicable, I'm saying practicable as far as feasible. Construction joint should be agreed in advance for an easy execution purpose, and backfill is a very important item. Backfill, and then we'll discuss about that. Now I'm just going wherever required, soil improvement has to be carried out to achieve required safe bearing capacity. As we see here, soil improvement, a question mark, because why soil improvement? That point we have to understand, we have to discuss. It's not easy just to accept something because we have not to understand. Soil improvement is very, very important activity where we don't have good soil formation. We have expensive soil, for example, somewhere, and expensive soil like clay, black cotton soil, or some other soil of equivalent status do not permit good foundation to be laid on them. Therefore, that soil may be condemned. It depends on consistency of soil. And if we have to remove that soil, we have to remove that. No way, no. And that's very important part, because it's better to take off that dirty soil, that irresponsible soil, and place it with granular bed or you can say graded granular stones where and filled with further smaller size and size. Like that, we'll explain the AnnexSL. Our question: soil improvement must be carried out to achieve required say bearing capacity and other properties inculcated to in the soil. Other properties, parameters, liquid limit, you can say, like for example liquid limit you can say, or you can say other limits as well as liquidity index, all we have to consider, or shear strength or bearing strength, how to improve angle of repose. All these points must be taken care of according to soil mechanics and soil engineering, soil parameters, which we can discuss later. And then of course imported desert fill or graded fill has to be used for purpose of limiting liquid limit as well as plasticity index to a minimum value as well as just as immediately. Imported desert fill or graded fill requires to be used for purpose of limiting liquid limit as well as plasticity index to a minimum value. Backfill is one activity that makes a lot of difference on future of foundations. It must be rightly conducted in line to project and general specifications. Observe that site engineers try to neglect this important item. They try to neglect its supervision when it's carried out and save project time by filling thicker layers, which is not a good practice, which cannot be accepted. Backfills materials should be conducted in good compliance to agreed specifications or expected strength to achieve 95 to 98% field density. That's called general fill. Can be lesser than that, but this is structural fill. Or like we replace soil, it's 95 to 98% field density of proctor density, which we received, we got it, obtained it by testing soil fill sample. General fill can be compacted to 90% field density. Now, we are just going to talk about certain construction sequence, and this should be correctly followed during scheduling stage. Foundation should be, this is just very few for purpose of reference, for purpose of information. So we know what we're going to do. Foundation should be planned as far as possible to be cast monolithic. So monolithic casting, you can say, columns should be cast first. Of course, priority it is. And beams and slabs should be cast one time monolithic. That's also a requirement because I have seen people here in buildings, they do not think about this. They do not even consider this. They raise walls together all and then they use non-professional way to fill in those columns where structure should take load, not walls. They forget this and increase rigidity of structure. So first point is monolithic action of concrete. Second item is stage of first casting, that's columns, and before this of course foundations, but columns cast first, and then we can say beams and slabs should be cast one time monolithic. During all connections should be conducted made to meet requirement. Connections mean joint connections, is to be ensured that proper bands are used in brick or stone buildings that being required for earthquake resistance. These bands means a kind of beam around a project. That's an important point, and particularly at door top level. Beams and slab monolithic connection should be made. I'll discuss this. Just give me 5 minutes, I'll be back, because that's also an important one. So we can say that, please excuse me for 5 minutes, I'll be back. And meanwhile, you can read this important presentation. Of course, everything is important, but if you read yourself, It will be better idea. And meanwhile, I'll be back. I'm just going to terrace of second story. A steps I have to go to 58 or 52, A6 and 612 and 30, 26 and 26. 52 and 12, 64 steps I have to rise and then come down. Let us enjoy like this, you know. little late because of the reason I'm back here. I'm back here to you. I think you have gone through. You must have gone through this explanation, which is construction sequence should be correctly followed during, I can say, construction sequence should be followed during scheduling stage. Scheduling stage, because scheduling is very important item. If you can't understand schedule, construction cannot be done. That is very important part of this. Foundations should be planned as far as possible, because monolithic, that's first requirement. Monolithic casting, then column should be first in superstructure as well. I mean to say real structure or usable structure, occupying structure I can say. So column should be cast first, and then beams and slabs should be cast one time, and that's called monolithic casting. All connections should be made to meet requirements, and make sure that proper bands are used in brick or stone buildings that have been required for earthquake resistance. Particularly, these bands are required in earthquake zone 4 and 5. 4 and 5 are risky zones, and if you take into considerations that these bands at grade level, lintel level, or others, and additional bands can be provided, keeping appraised considerations of possible earthquake forces. Long walls should be inserted with bonding columns and bonding beams as required in specifications. Long walls, I'm not talking of infill walls, I'm not talking of structural walls, because I'm not talking structural brickwork or structural columns, I mean structural stone walls. I'm talking of structural long walls, which are only for infill, which are only for purpose of infill or cladding or closing gaps in frame. Framework construction, but this doesn't happen generally here and it's not acceptable. People do not know this technology, they don't understand. Actually, they can say what's good, what's merit in that, what's demerit in that, and whatever is advised to them by illiterate contractors, illiterate promoters, illiterate in the sense non-understanding of engineering theory. These tradespeople, these artisans, which call them carpenters, masons, or experienced professional tradespeople, what they advise, public follow them. That's not correct. They don't have to talk to professionals like engineers, and that's drawback, you can say, in public life. Connections between columns and walls should be made with proper fastenings. Fastenings we will discuss. This is column and walls, which are connected together. Walls, brickwork walls, or concrete hollow block walls are connected to columns by fastenings, which can be, you can say, wall ties, fired wall ties shot into column. That wall tie remains in course of block masonry, and that's what we call fastenings at every third layer. That's called fastenings, or shot firing this wall ties through bullets into concrete. That's what I'm talking about. Factually speaking, all construction activities must be complied with designs as well as specification requirements. So we say, factually speaking, all construction activities must be complied with requirement of design as well as requirements within specifications. No ignorance or negligence can be allowed during supervision by line management or line organizers. Quality engineers must similarly they must check and inspect all activities by observations in addition to formally signing inspection and test plans. Engineer's representative, resident engineer, should keep an eagle eye or concentrate on all significant activities. Quality products should be, or it be a must requirement for delivery. No quality product means no product. Now during earthquake occurrence, buildings services too can break due to impact by horizontal forces and vertical forces, which require strong and durable fills around with durable joints. All elements of buildings as well as finishing should be well secured and constructed durable so that during seismic action or earthquake impact, these do not dissociate or tear out. We will get explanation, no problem, just as let's see points of attention, brief points of attention on site. What should be point of attention? Site engineer should not decide self about any engineering design or engineering decision on mistakes for any reason whatsoever. Many aberrations from quality compliance and their suggested solutions are noted as follows. Rusted and bent reinforcing bars are often delivered either to site or to fabrication yard, which are without thought included on works. I was just reading first. Straight line or straight length without rust only should be used. Reinforcing bars are placed on ground soil or ground level and not on raised platforms or good wooden or other supports without covering with polythene sheets. Precaution should be resorted to for good handling and storage of reinforcing bars. Fabricated reinforcing bars are not properly stored. Fabricated reinforcing bars are not properly stored and sorted, tagged and stored in a shed or under protection from moisture contact. Right tracking should be maintained by designations of relevant elements. Reinforcing bar dowels may be forgotten to place in at various locations of joint connections. Chemical anchors should be used for forgotten dowels, and that depends on availability of such anchors. Do not chip concrete and insert small hook. Drill shall be required to fix in chemical anchors to manufacturer's recommendations only. Inserts, embedments, respecting services at various locations may be missed. Approved shop drawing should be used for inserts locations. Coordinate inserts location through structural details. Blockouts for various services may be often missed due to unplanned working. Approved shop drawing should be used to overcome such problem. Coordinate these locations to structural details and services details. Sometimes due to site negligence, certain concrete elements inclusion work may be missed by overlooking. Structural drawings should be deeply coordinated with architectural drawings. Generally, facets dowels are forgotten. Many lintels too are overlooked. Opening or bulging of forms at one-third of height from pouring base is a common occurrence. Location requires strong resultant supports to resist forces. It should be taken care of while considering concreting plan. Chipping should be avoided if feasible by providing strong supports. Honeycombing on surface is a common defect occurrence. Vibration to concrete should be applied rightly without segregation. Produce a smooth and a nice surface of concrete for a good delivery. Concrete temperatures are not ensured in range of 5 to 32 degrees Celsius. Concrete is carried out within temperature about 35 to 45 degrees Celsius, which is surprising. Now during higher temperatures as such, ice requires to be added. If mercury is about 32 degrees Celsius or say about 35 degrees Celsius. Thick elements of massive blocks should be concreted within 24 degrees Celsius. Voids formation in concrete is a common occurrence due to lack of compaction. Void areas should be chipped out to reach strong concrete surface, hard concrete surface, followed by remedial treatment, chemical treatment, or otherwise, or for repairs use recommended chemicals, whatever you have to do repair with. Exposition of reinforcing bars is also a common occurrence on concrete members. Mortar is pasted on those areas to hide exposed reinforcing bars, which is a bad practice and unacceptable. Concrete spacers should be placed all over members from surfaces to meet correct cover or spacer requirements. Congestion of steel is generally, as experienced, not anticipated by site engineer. It should be discussed with design engineer when heavy congestion is anticipated for an alternative detail. If workable, better arrangement should be approved for action on site. Reinforcing bars are often displaced by electrical conduits fixers. Electrical conduits fixers. They displace that during work. During conduits fixing, steel fixers should replace affected reinforcing bars parallel to conduit installation. For higher size bars, overlaps do not work perfectly. Mechanical connectors should be used for both horizontal and vertical bars. Generally, reinforcing bars that 20 torr and above work better when mechanically connected. Hardened concrete is as a bad practice cut for passing a small air conditioning. Do not say hardened concrete is used for this nonsense. Means for passing a small air conditioning duct already missed. It should not do that. No concrete should be cut without proper investigation by either design engineer or resident engineer. Excessive slump is not reported daily. No information should be concealed, but slump should be tried to be brought down by keeping truck mixer rotating for a couple of minutes. In case it doesn't work, to reduce slump to acceptable standard limits, mix should be rejected. During concreting pour, due to delay, additional water is secretly added by foreman or someone else, you understand that. No additional cube sample is taken for added water batch. If additional water is allowed to be added to concrete, special cubes should be collected for specific strength confirmation test as well as slump test. Construction joint stop end is not readily available on site. Keeping certain emergency in view, stop end should be made readily available. And if required, it's fixed as an emergency exercise when concrete stops due to whatever reason. Construction joint is not correctly fixed. Construction joint location should either be indicated either on drawing or should be agreed with resident engineer prior to commencement of pour. Construction joint is not correctly hacked or scabbled. Hacked or scabbled before new concrete is laid. Do not run fast, but chip out joint surface to expose aggregates by removing latents and then proceed for laying concrete for new work after a lapse of 24 to 48 hours of pouring old concrete. Standby vibrator is not available. It's very important to have additional vibrator to meet working requirement when a busy vibrator fails. And vibrators should be checked for working before commencement of pours. Curing is not started in time and curing is not continuous as required. Hot weather requires immediate curing, particularly on exposed or unformed surfaces, which can be done by spraying curing compound evenly immediately after concrete is leveled and finished. Polythene sheet can also be spread on concrete surface immediately finishing is effected. Curing should be effectively carried out to defined duration by personal attention of site engineer. Curing is not completed for required period. Do not ignore curing. We will discuss these points also later on because it's long list, and meanwhile I'll just like to explain some of them because we cannot continue and forget past one. So what we have discussed so far are briefly, wherever possible, I like to explain, and then I can say that just running is no use. We have to just clearly understand what's talked of. Before going to somewhere else and building house in say, let's say we'll discuss this as well, and all that if possible, in terms of understanding. And just few I'd like to explain briefly on this issue of what I said so far. That is, these activities I explained to you, these are brief activities. Let us consider what I mean by site takeover. Yes, we take over site, that's right. I mean to say, I suppose I'm a contractor. I or a contract representative, it's my duty to take over site from engineer or from of course engineer represents client owner, and I take over that site officially so that takeover day, you can say actually this is my start of project practically. Then takeover doesn't mean just takeover on paper. It means you have to plan for that. Plan for what? Plan for mobilization. You have to mobilize that site if you are a contractor, because every day is important for you. You cannot waste even a single day. If you waste your own contract time, your contract money, your liquidated damage is invited. So taking over means planning and mobilization. Generally, on contracts, major contracts, there's 1 month always given for mobilization period, and which is not very long period as well as not short period. It's neither long to short, no short, but mobilization has to be done, and mobilization can be done only by being ready on site to start project permanent works. So planning is required for the planning of what? Planning of site means how you are going to stay on that site for say whatever given duration. It may be 1 year, 2 year, 3 year, or whatever. Or you can say you must have your own office. You must have your established office for that. Your supervisor, your engineer, your resident engineer, and you must have place for your subcontractors. You must have place for your own people who will work in steel yard, who will work in carpentry shop, who will work somewhere else. You must have some place for store. You must have some place for parking. You must have some place for something else, and all should be clear from working area, possible working area of contract. And if there is a small place you don't have that, then you have to take some other site locally, or you can say you take some pay money for that, or lease, and on lease you have to take that site for. This is called lay down area. Means lay down, you have to bring material, where you keep that material, you have to bring machines, where do you keep those machines. All this must be taken care of during planning and mobilization, and that's mobilization is very important time, because if you don't waste this time, this 1 month time is very important for contract, because there's a preparation time, and this you can say I'm going to be ready in 1 month time, and meanwhile you must start permanent works immediately mobilization, or you can overlap that and start middle. So that planning is required, though it's planning of total schedule, also it's planning of complete schedule also, but this is also planning for the site immediately. It's not necessary that you should use the sketch planner. You can do yourself, means you can have a sketch with you, and you can say, okay, we will do like this, means this is my office, contractor office, this is engineer's office, resident engineer's office, this is our yard, working yard, and this is our storage of steel, this is our storage of other material. Of course, the mixer is not required because we take metal for ready mix concrete, but this is our site, and this is this location, this entry of site, and the exit of site, how to take relation. And it means you should make in such a way that your work on contracts are not disturbed, and that's called establishment planning, or that's called, you can say, a planning to start job in offices, establishments, and others. Everything is fixed, and there all of the labor working, their residences, your staff residences, everything should be brought into consideration for making certain decisions, and that's called mobilization planning. And planning, your planner has to do for whole plan that goes on parallel. It can be 2 weeks or 3 weeks it takes, and to make all plans, number one plan, level one plan, you can say master plan. So takeover is one part. When the meeting is considered, let us take over, and then we start planning and mobilization. And mobilization, of course, during mobilization, you can see during the startup that you are giving some advance money in contract. Depends on what contract is, and that money is taken, and mobilization is done. And that mobilization cannot be charged immediately, because this is mobilization for contract because so proportionally money is paid to contractor. That you have done mobilization, okay. And there are so many things left in that, but on gross we can say you can start your site work initially when mobilization is over, and this mobilization is a part of execution of work. We can define this as a part of execution, and there's a method, execution method statement, which says how to take from point of takeover to point of delivery. That's the execution, how you are going to do this. So this mobilization can be reflected into that execution statement as well, and also you can say planning element can come to that. Then of course we come to surveying. What's surveying here? Surveying is a very important part of project. You cannot do without surveying, because it's civil engineering based on surveying, and that surveying is these days done by GS system, and GS, and that's a very important system. Means you are given real coordinates as well as real labels. There's two horizontal controls which is done by coordinates, and the vertical controls is done by labels, or reduced labels, and you have to establish those labels on site according to your design. But these labels and these labels are irrelevant, they're given in relevance to GI, or they also know you are just take from site to some music. It depends on what design is and what information available you have. Sometimes they don't give actual levels, they give something else, and they say, okay, this is our benchmark. You take from this is here this point, this is level, and here is this point, this coordinate. Or you have to take from system, global system, and global system gives you. You have to hire someone who has that knowledge, who has that capacity to certify that as well. So those coordinates, latitude and departures, north, easting, north and south are brought to your coordinates, your site, and labels are also shifted from that one. So we have to establish label marks on site, we have to establish coordinates on site, and from those your regular survey will do that, survey which works for dedicatedly. This may be a third-party surveyor which will provide you on site, and you have to pay. Sometimes the certification is also obtained, and deposit, the service deposit submitted for reference to your resident engineers. So we say takeover is there, planning is there, planning continues for a couple of weeks, and that master plan is submitted for approval purpose, and then followed by that there are many other plans like level 2, level 3, level 4, level 5, etc., etc. and then mobilization continues for 1 month, and surveying starts, surveying of your works, permanent works, whichever you have to start immediately. That survey is the setting out coordinates are done and all that. That's where we have to stay. So further stages of talk surveying. Surveying is an important part. You're taking the survey, establish your coordinates of site, and establish levels in site. So you can say this is my benchmark, this is level 00, like consider that one. You can consider the real one, or you can consider 00 level according to design. What levels are given in your design? I think your design must have, your drawing must have levels up to 00, or it must have real. You can establish, you can convert those levels to your site levels, or you can do the actual levels. I think it's better to consider your site level and establish your real level, the site levels. Consider geoscience data because take so many meters down, and on site you can say you can formation level is so many downs, and this first floor or ground floor there's so many meters. Surveying is like that. Establish coordinates, establish your site levels, and then continue with that. You have to from setting out on site for purpose of excavation. Setting out means layout of your site. You have to fix surveying activities completely, methods of that, vertical railing, timber railing around or whatever railing. And then you have to start, kick off project. And construction starts along with mobilization sometimes. So once mobilization is finished, construction starts, kick off starts. It depends on your means kick off meeting is already there. You can say work is kicked off and kick-off meeting, take over site. During that kick-off meeting can also happen. Then you can say continuous construction goes on without any stop. And of course, when construction goes off, quality has to go off. And don't just consider quality as material quality or activity quality. This is quality of system. You must have a quality plan submitted, project quality plan, which must describe responsibility of everybody, which must describe what methods you will use, which must describe inspection, test, plan, checklist and ITPs for all activities, important activities, which must describe how you are going to work on site, what sort of submissions you have to do. Like this, which are required: material submission, statement submissions, drawing submissions, and whatever submissions we have to do. Quality plan. Also, we have to do safety plan, which is not mentioned here, but that's also important plan. Safety first is criteria. So quality plan, safety plan, or project plan. These plans are a must, though not according to ISO 9000 system. It was before in 2008. ISO 2015 has granted some concessions, but it also states if you prepare those plans, if you adopt those plans, then it must be established that you complied with them. So there's no way you can avoid that. They give me a concession, but that concession is momentarily, because without those documents you cannot move, and if you move without those documents you will definitely won't get quality work. You won't get quality system. That quality which I'm talking is not just quality control, it's total quality of your project system, including your organization or your company's corporation. Then comes supervision. Supervision, that is very important part, both supervision, resident supervisions, engineer supervisions, and your own supervision. It's continuous, a whole project, continuously, depending on works, and then completion maintenance. Now, organization, as I said, I explained to you about cadres of engineers on behalf of owner. Engineer is there, who is appointed engineer in terms of contract, and resident engineers, that's representative. And in terms of construction, there's always contractor, and contracts are representatives called site agent, site engineer, construction leader. And all these plans must be prepared by those people and approved by engineers representatives and engineer itself. And then it's a very important document, site plan, quality plan, safety plan, or you can say project plan, and along with that your company quality policy, whatever you follow, and their roles are defined: role of engineer, role of resident engineer, role of specialist engineers, and role of site engineer, role of site agent, role of other agents, like that. I just try to explain to you basic roles. It's not possible to describe each and every detailed role. On a gross understanding, you can say one has to construct, other has to supervise. Engineer means contractual, defined in contract, and resident engineer is appointed by either engineer or owner. And contractor is appointed by owner on recommendation of engineer. And contractor is a party, and owner is a party. These are parties. Engineer is no party. I'm telling you, engineer is a third party, like independent person who is paid by owner but who has to work for project, who has to supervise and control contractor. And financially, owner is responsible. Engineer is responsible to only that extent that budget is there. That engineer cannot cross that budget until it is approved by owner. And once cost is fixed in contract, there's lump sum price for this contract that cannot be varied. These are also important points. So soil action comes in time when you start something. Soil should be properly understood, and you have to understand that in totality, or you conduct your own test. It also says quality engineer. Quality cannot be compromised. Quality engineer's responsibility is to take care of internal quality system of contractor as well as quality controls of materials. And soil must be taken care of by all. That soil gives same equal properties, equal strength, equal capacity as has been taken into design. That must be made sure. And all this is done by these professionals. And testing of all materials is mandate. You have to test all materials, all important materials. You can't do without that. And if these materials do not comply to requirements, cannot be accepted. Concrete trial must be done, though there are available designs also, but it's better to do trial test for purpose of bigger projects. Or you have certain concrete details available from ready-mix plant which are very recent, proven one, you can refer to them also. In that case, I think trial testing is waste of time. If this thing is competent, consistent, it's proven. And the piling is very important item, on high-rise, low-rise, where there's weak soil, you have to go through. That's very long activity, very time-consuming activity, but it's must. Piling, as far as driving is concerned, also piling, casting is concerned, it's not big time, but testing takes time. Testing load test, integrity test, and all that takes time. Then pile cutting takes time. Like this, pile cap takes time. But that's out of means you have to do it. And then various roles I have explained to you. These roles. And of course, in these roles I said that site engineer's duties I discussed. That all drawings, all documents, whatever is given, it's duty of site engineer and resident engineer to go through all them and coordinate. Coordination activity is above all activities of disciplines, because coordination talks, during coordination each drawing talks to other drawing, each specification talks to other specification. They talk in unison, and if they don't talk in unison, there's a war, there's a conflict. That conflict must come out. That's purpose of coordination, to find conflicts and solve them. Because if you don't coordinate, you'll make mistakes on sites because of drawing errors. And you will blame, this is drawing, what can I do? Only you could do is coordination, which you missed. That's point here. That's also a part of quality functioning, you can say. It's not quality control, but quality functioning. So whatever drawings we have, whatever standard drawings we have, whatever materials we have to see everything that falls within category of requirements, and these two, that's main role of all parties. Then method statements, I say, is an important part in this case. As I usually say, method statement, as said here in quality design custom method statement, is very important role. It plays very important role, as I remind you all these points here. All these points work on projects in form of applications, and these are very important. If you go without them, you make mistakes. That's what I'm saying. So, all then, important point about steel bars I'm very concerned with should be why people miss that. I don't know. It's duty of site engineer, it's duty of consultant or resident engineer to make sure that work is done according to drawings, and also to make sure that materials used are according to drawings. And if you are using, for example, bent bars, means you bring bent bars from factory itself, you buy 12-meter bars and bend it just for ease of transport. That is nonsense, I say. You cannot do that. If you do that, you make mistake. First of all, you bring new bars. You don't use recycled bars. You make sure whatever material you are taking or buying, you must adhere to requirements and specifications, and whatever mill checks, mill scale says, mill test says, those must be accordingly. Those certificates are not for namesake. These properties must be, and if required, according to size of contract. These bar species samples can be tested, must be tested, sent to laboratory for test. And all bars must be brought straight, and new bars can never be rusted. First requirement of delivery, after delivery, is that you have to store them properly, store them in such a way that it's neither affected from ground moisture nor affected from moisture available in weather, in environment and atmosphere, as well as no effect on by rain. So these must be stored little above ground, say 130 centimeter to 45 centimeter above ground, or to whatever extent possibilities. You can make some platform, good platform by block work or by timber framing, and you can just raise these parts from ground and cover them with polythene sheet so that no moisture can affect them. And that should be the polythene sheet should always be there and stored, and even after fabrication they should be stored, and even after laying and placing on your members, columns being aware until these are exposed and not concreted yet, must be polythene closed, polythene wrapped, and even slabs must be wrapped. This is very important point, though it's not expensive as a matter. It's just very momentarily, and you can do that. You generally don't do that. I don't find this available, this procedure anywhere in our country. I think it's ignorance only. Every engineer understands that this will rust it, but they accept that, unfortunately, because they don't concentrate on that. I raised this question to many engineers on Facebook. Your photo says this parts rust, why are you having them? I don't get any answer back, but it happens. So rust is not allowed. You have to take care that bars are straight, bars are not brought banged, and then not straightened, and they should be rust free. And if by chance you can't do that, then you have to blast them. You have to sandblast them to remove rust. No way. There should be no rust on that. There should be no oil on that. That's duty of resident engineer to make sure that it's not rusted and not brought bent. Also duty of contract agent to make sure same thing. And that's an important point. So here, as I said, these are regarding steel. And we have to make sure when steel is cut according to shape code. It is BSS 446 was before, now it's 8866. If BBS is made, cutting length is indicated, it becomes easier for person who's chopping steel, cutting steel and bending. Cut length is more important, then you can follow shape. That's not very big issue. Cut length is important because it's difficult for those artisans to calculate. They take a lot of time. So you calculate yourself Excel sheet produce cut length, give shape, and then fabrication becomes easy. Then bar bending schedule is a schedule as well as a tool to help help all this. Now overlaps should be avoided in higher dia bars because these cause problems. The overlaps not successful actually. In higher bars, better to use connectors. And of course, there are ways to fix details and make on site in such a way that this becomes ductile detailing during earthquake action. So it should be remembered that in earthquake time, these bars change their stresses. They work differently for seconds only, for a few seconds when seismic actions, horizontal actions on building work and vertical actions are disturbed. So you can say buildings behave or conduct or response in rocking manner. And that manner is very difficult. For that purpose, maybe some of your bars, some of column vertical bars who are in compression bending, start behaving crosswise by this force to some extent, say up to 25-30% of horizontal force in relation to vertical forces. So that way this can affect, so that part of column can become beam at that time, and that part of beam can become column at that time, and your diaphragm slab can become horizontal resistance. It can act also in that way. So all elements of your structure change behavior, and that behavior goes because of rocking of structure. It goes impacts on foundations as well. You have done. So foundation can also move, of course, not to that extent, but it can move because horizontal actions is strong, very strong beams are there in foundations. So horizontal may not impact, but that will transfer this load to above. Therefore, it's said that you have to consider very importantly provisions of steel bars into this for purpose of this one, and ductile detailing or ductile action is very important. And I would suggest don't follow only theory, use some your practical experience also, and that can be different way we can define a design part. And also how to do concrete, that's important part, important matter. We people are not clear of that. We must take care of that because some people play with concrete without understanding how they lay concrete there and then use vibrator to pull it, to push it, which is nonsense. It segregates concrete, it destroys concrete, and purpose of vibration is ruled out, means no meaning of vibration in that case. It's bad habit. You must train your crew for purpose of vibration, and vibration bad means concrete is bad, and you have to be careful about that. So you have to do everything. You have to do everything and see how it happened. You must study. It's very important. Practical study is very important in concrete. Theory is not that important as far as work is concerned. So don't over vibrate, don't under vibrate. Really vibrate at a vibrate in a fine way. And all concrete should be vibrator. No voids are allowed, and if are allowed, you have to investigate how it happened and you check it, correct it, set them right. Cover spaces are important. You use plastic covers, use concrete covers in the sun. People don't use cover and they destroy concrete. They use it baseless instead of baseless. I mean to say cover is a very important part because it first of all gives cover thickness to steel so that penetration of water becomes less. And also it acts as a fire resistant material. Has much more cover, more fire resistant concrete is. Then formwork must be taken care of for safe design. Working safety of utmost important, and we will review this in later on. Now let's go to see what is your actually I was talking of this what was that, where is was, I'm sorry, I could not see which file it is. House, I'm saying this, yes, this one. I was talking of house building, and I explained to you last time, but I could not because of voice reach you properly. So you say refer to chapter 3. I'm still that regarding safety, focus safety. This moment I'm just talking about just it says safety issues, and it also says that activities, how to take care of organization, how quality is done, and then the layer of safety. Then building NCR, like purpose of this math statement is described briefly. Procedures that are adopted for harness construction. Engineering synopsis, the basement, ground, first, second floor. Let's revise this file first. It's what we want to take into our account. It's only a few pages. And you can say certain sketches also involved. This one is sketch here, architectural sketch. You can see the sketch here, and then also there's another one, another figure. This is structural one, and also there is, you can see that this is foundation section, not footing, foundation section, continuous beam foundation in below ground, and this same section continues like a track, like a track but reverse track. It goes on, and it moves connecting all columns in net, and it's called grade plane, or you can say horizontal frame of foundation. Means loads are vertical and the columns concrete starts on top of this beam, which is here. This concrete columns will start here, but still will go in below. And this is your strip, not strip beam, foundation beam. And this is soil improvement here, and that's what I want to talk to you then. You can say also there's then this is elevation, this is another elevation, this is this is another elevation, this is plan building. And this is important plans, foundation plan, you can say, part in this building will strip the beams which are talking about. All these beams means if you take these columns are connected by beams like this, This is a part, this and here you can see this is same steel which I was talking about. This steel is same, just giving you short here so that you can understand. This is same. This is dampener. This is main beam, and this is rings in. This rings in here, and it's not very big, only 800 and 20, 200, 100, 200, 200, 200, 300. So this is only that much, not big. You can see this also here. Also here, this is foundation, and in this case also foundation, but this portion has been used as water reservoir, and this also foundations, you can say. This is just for information, we are going to discuss, and also important point was it. It's a very important point here. I think you agree with this type of foundation. This is like a stool. Means when you force air, apply force air. This will not go away because of this base frame. And then this is excavation plan of this. Just blow it up for showing to you. It's excavation plan, and same beams as this portion of the excavation would be done. For a ramp shall be available from other direction. Could be from here. So this is where columns and beams are connected in this year excavation plan. Then we can say here you are learning, we'll explain later, but I'm just saying what learning is that's points are important. Let's say what we learned actually. Then going further, what should we learn? What have we learned? That point is also important. That's quality requirement is more significant than quality awareness. Quality requirement is more significant than quality awareness. Just I'm tell you before completing the I'll go review this. Quality requirement is more significant than quality awareness. Quality requirement must be binding. Living chalta hai or quality last attitude, written off forever, to be replaced by think karo, or quality must. Do right. Quality must. No way that quality last. Quality first. Must. Quality first and quality must. No way quality last. Quality systems requirement must be adherently applied from designs to tendering to award to supervision to execution of construction operations as well as post-construction maintenance. Merely signing of document is not sufficient, but carrying out of activities and 100% inspections or examinations are mandatory, must be mandatory. Those personnel involved with quality system operations must be themselves quality competent as well as quality supporting. And must campaign for its reality achievement by encouraging other departments' personal responsibility, ignoring personal spoil rate. Also, those personal, merely signing off documents not sufficient, but activities are sufficient. Carrying out activities 100%. Inspection must be conducted, examinations must be made. Mandatory, not only made, those personnel involved with quality system operations must be themselves qualified, quality supportive, quality understanding, must campaign for its reality achievement by encouraging other departments' personal responsibility, ignoring personal spoil whole system quality. Lapse on quality cannot be digested in any case. Lapse on quality cannot be digested in any case, whether activity belongs to pre-earthquake preventive measures or belongs to post-earthquake disaster management. Loss of lives due to negligence cannot be compromised. Generally, it's been experienced that in almost all spares, after quality system introduction for decades, product quality has not resulted as expected. Consequently, by inefficient compliance of quality system, lapse of quality on performance and its inefficiency cannot be allowed to be digested with any disaster mitigation. Scenario whether it has to be in operation or it has to be as supporting resources or as involving leading authorities, whosoever and howsoever, big one. Then you can say lapse of quality and performance and its inefficiency cannot be allowed to be digested with any disaster mitigation scenario, whether it has to be in operation or it has to be as supporting resources or as involving leading authorities, whosoever and howsoever big one may be. Hard work input, determination, dedication, commitment, implementation, post-implementation, secure scrutiny or audits are all must be seen duly performing in addition to approved or recognized agreements. Bare talks and statements would not work to give required results. Real action must be seen doing by one and by all members of all departments team. No leniency should be accepted on doing any activity to requirements in any department or section. Safety first and quality must. Safety first and quality must attitude must be adopted as strong potential slogan. Can we understand this? Since what has been changing in our country, our nation has to change, otherwise there will be no way to escape from due responsibility and legal liability. No safety, no pain versus no safety, no pain. Understand this? Spelling is different. No safety is KNOW. No pain. If you know safety, you have safety. There's no pain. Well, we can say no safety, no pain versus no safety, no pain. Can we understand now? Other buildings, let's say just a half-page talk I think is left in this, but we will go on this document again for reading, as it's a very important document, I can say. Now chapter 13 discusses this for officers apartment flat, officers apartment flat and an administrative building respectively provide more proposals for construction purpose. As this, I will see this sketch as described in foregoing. Similar sequence for respective activities should be followed. All such buildings are RCC structures with internal and external finish on some same pattern or scheme. And there's a sketch shows central control building which constitutes part of major facilities project with wide dimensions. Purpose of such building is to house all central controls that are required to control all processes strains on then you can say a sketch shows central control building which constitutes a part of major facilities project with wide dimensions. We'll show you sketch. Purpose of such buildings to house all central controls that are required to control all process strains on a chemical processing plant. This type of building is located off-sites in processing areas. Such a structure must be blast resistant or resilient depending on this, due to the fact that its distance of extreme corner lies within 200 to 600 meter of process area, location for which sketch number other one indicate facility layout. Sketch doesn't show complete details of setting hours, but only that part which requires blast resistance that can be provided, including RCC walls on peripheral areas, periphery allowing blast resistant steel, allowing, you can say, allowing blast resistant steel thick doors on indicated locations, or if so required on other locations as well. This type of building, CCB, central control building, should have IT access room as well with raised floor system to contain optical networking, supporting arrangements, cabling. CCB must have device with all equipment that it will be required for total processing. Controls and should have adequate accommodation capacity. Now it says CCB type building should have IT access room with raised floor system to contain optical networking, supporting arrangements, cabling, etc. It must have device with all equipment that would be required for total processing controls and should have adequate accommodation capacity as well as internal circulation areas from safety and ergonomics viewpoint. Entry locations. Entry locations should be provided with airlock doors and trace. Internal control should be provided with access card system or other security and surveillance system. CCB must have integration with CCTV network. SCADA controls. SCADA stands for supervising control and data acquisition, etc. CCTV, central control television, and then supervisory control acquisition. Supervisory control and data acquisition. Then there's sketch, gives line plan for substation building, which requires blast resistant, without blast resilience or resistant designing. When such building is located within 200 meters from process area, it should be blast resistant, and accordingly RCC walls and slabs should be provided, while no precast elements preferred on such buildings. When located between 200 to 600 meters, it should be blast resilient. And when located more than 600 meters from process area, it could be non-blast building, an ordinary structure involving normal loads, wind loads, and seismic shear appliances. Then we can say is about when located more than 600 meters, it could be a non-blast building, an ordinary structure involving normal loads, wind loads, and seismic shear applications. Substation constitutes cable sealer, high voltage switchgear area, transformer area, control offices area. And walls should be of RCC constructed for blast resistant case in addition to RCC roof. It's still going on, I think, yes. And also, walls should be of RCC construction for blast resistant case in addition to RCC roof. And RCC column should be constructed for blast resilience case of addition to RCC roof. Walls should be concrete block with normal reinforcement in voids, horizontal alternative. Alternative courses constructed for blast resilience or non-blast resilience. Walls should be concrete block. Walls should be concrete block with normal reinforcement in concrete hollow voids, horizontal alternative courses constructed for blast resilience or non-blast areas. Precast slabs of walls should not be used for blast impact locations due to no viability. Transformers, party walls should be RCC constructed for blast as well as for fire loading. That is transformer party walls. Means between two transformers, it's a party wall. For all such critical buildings in process areas or in offsites, adequate provisions should be made for loss prevention utilizing either FM200 system or energen gas system, which performs on basis of consideration that during fire area in scope is sealed in seconds, allowing no fire spread. A sketch shows another sketch pertinent to sectional tank, respecting water storage tank in plant where no single unit tank can be useful due to certain reasons. And single unit tank doesn't allow continuation of water service in case of problem is involved with tank, but sectional design can allow continuation by affecting affecting sectional cube. So tank can show four number vertical layers as well as while it's the 50 number units horizontally in each row, which arrangement capacitates to defined quantity. Tank has to rest on ground for which foundation is required. Foundation beams have been located. Alright then, let's say tank has to rest on the ground for which foundation is required. Foundation beams have been located to bear load in such a way that end beams carry weight load from one unit mount on stack only, while intermediate beams carry from two unit mounts on stack. Whole area requires execution shallow depths, compaction, blinding concrete, protection, concrete, formworks for beams, steel placing, concrete pouring, etc. A pump shed is also required. We construct adjacent to this tank by installing a pump filling the base or machine design calculations. We'll go through this long way to explain to everybody how it works, and that's an important point. It's just shown you something. I'll see how to take further, how much time to give to this one, and I'll just trying to just see. And I'm going to do non-plant buildings as well. What are those we talked about? This blinding concrete we discussed, and then we discussed many other items like steel fixing, framing, and also we did block work and we did plaster rendering later, and also we did the plastering rendering, block works and also surfaces, and we also did this is roofing system is very important one. We have talked this roofing system, right? Roofing system we talked of, and of course, then we went on to laying ceramic tiles, floor tiles, improvise, and of course we are going to screed as well. Building drainage we did, and we did then floor screed, one floor screed, and of course then we went to concrete interlocking blocks. Of course, roads working die. So concrete interlocking blocks and road works, and also preparatory works for pertaining reinforcement placement. Pouring concrete and then post concrete repairs. Of course, then we can say another statement, that is Series pipeline, I think there's end one here. So this is regarding on plant buildings. That's the problem here. So I'll go back. And there is also, can say, I say, and then force will just meanwhile I'll be back in 5 minutes. So, we like to take now time for today's closure. It's already 7:15, and live takes few minutes more just to review what we did today. We here did about quality, designs, construction, method statements, time, cost, risk, reliability, analysis, synthesis, thinking, contemplation, application. These are all maybe modern sequences we have to understand. Application is a result which is based on contemplation, thinking, synthesis, analysis, reliability, risk, cost, time, method statement, construction, design, quality. And we can make some more sequences like that. It's not a big deal. It depends on their experience. And then we talked of role of site engineers. It's a very important role. We talked of, and it's a very important point we should take care of. A role is in your hands to define what responsibility one takes. So role becomes that. It's not necessary that these are hard and fast rules. These are just indicative guidance. Means whatever position you have, whatever role you define, what work you are doing. Maybe you have 2 positions, 3 positions, 1.5 position, or 0.5 position. It depends upon you. So we have to go through that in a kind of review sometime later also. And that's the important one. That is all what I said. You have to understand, and then we have to take care of these certain methods which we did. And I tried to show you all this. That all this very few statements, a lot of statements will project to you in coming time. Because just by document share or screen share, we can do it better than going only in talks. I don't want to show my face, but my work is important here for your benefit. And that's what means we will move forward. And that's all I can say. It's all we can see. It has to be done like this, If we move fast, because the time scarce, we can say, we can go like that. And there are so many files as such in my system. I didn't want to combine them because it takes a lot of time. So, but we can say that, So, also here is what I say. I'm talking of house. I talked of this house. Something to be done with that. We'll talk these 4 files together one more time for including all details. And I like to close this meanwhile. So today is just one small video on this, about 2 hours and a half. You can say this is gone case now. And then what I say, important point in this we cover related to this. So now I'll take this, and we can say that whatever we consider today related to quality. Quality is a very important point in engineering construction, because we can do it in the designs, we can do it everywhere else, we can do it in documents, we can do it in specifications, we can do it in tabulation, we can define everything theoretically sitting in office. That is easy. Whatever knowledge I have, you have, everybody has, we can just write that, express that in terms of documentation. But how much can we achieve? That's more important, because it's on site, practically, physically. That's how that's product for which payment is made, for which money is spent. All money that is spent on designs, all money that's on the planning, all money that's on production of documents and negotiation of content, money must come in form of product. Whatever product is based, that involves all those elements, all those discipline monies. That's cost on product, total cost. And whatever person buys that product, means user or buyer, that must feel that yes, I got quality system, I got all that. That's where it lies. Means the whole system must be quality based. You cannot say, oh no, I have done this construction quality, I'm responsible for, I'm responsible for planning, I'm responsible for quantification, I'm responsible for specification. Okay, everybody is responsible for everything, but what is responsible ultimately is product. If product doesn't come quality, despite its follow system, quality system, there's no meaning of quality system at that time. There's no meaning of your design at that time. There's no meaning of planning at that time if you don't get all that. That's a very important point. We must consider that, we must think of concentratively. We must use our energy on that, and that's an important point. We cannot ignore that. If we ignore that, we ignore ourselves. So with this point, I say one point is that I consider method statement a very important documentation for this purpose. And we have to take that into consideration. We have to understand that that's a very important medium, like a journal, like something, if you're writing, you write essay or something, is technical document which tells everybody what you have to do, what is required to be done. And that's very important point we have to take into our consideration of care. And with this note, I'd like to close this talk today and continue next time. And with this, I hope. Yesterday I made a mistake. I could not include voice, though it's not my mistake, it's media mistake, because I had some problem in voice. I think today it has been solved. So I can say, I say that if you respect, if you respect engineering, if you respect construction, if you respect something, we have to respect ourselves. We have to respect our professional duty, our professional requirement. And if we neglect everything, I think we neglect ourselves, we neglect everything. That must not be allowed. So quality, designs, construction method statements, and whatever we include in that, risk, time, cost, etc. And of course methods, and you can say whatever we include in that must be understood properly. But this is very basics of very basics of our system, our process. All these